All right, peeps, here's answers to page 3 in the packet. It's more practice on counting. So let's go through and check. A lot of different atoms to count, a lot of different elements to count in this reaction. And notice, it's easiest to kind of write it right underneath the arrow. It helps to keep your reactants and your products kind of organized. So let's see. So let's count the sodiums first. So let's pay attention to the coefficients. We just have 2 coefficients, a 3 here and a 2 there. So because of that 3, there's 3 sodiums, and on this side there's 3 sodiums. Hydrogens, there's 3 on this side, and there's only 2 on this side. So immediately this is not balanced. You don't even need to finish it. I mean, I will finish it. The bromines, there's 3, 2 on this side, they're not balanced either. Phosphoruses, there's 1 on this side, 1 on that side. Oxygens, there's 4 on this side, 4 on that side. Sometimes, by the way, let me just say this because we'll get to this later. Notice that's a polyatomic ion. Those are phosphates. Sometimes instead of separately counting the phosphoruses and oxygens, it's easier to count the polyatomic ion as a whole. And so on this side, there's 1 phosphate, and on that side, there's 1 phosphate. So anyway, all right, so that one's not balanced. Let's move on. You can keep counting these separately. So let's count I know there's not a lot of room. You have to do your best you can. Nitrogen, hydrogens, and oxygens. So on this side, there's 4 nitrogens and 6 on this side. So it's not balanced right away. I'll finish it. 4 hydrogens, 8 hydrogens, that's not balanced either. 4 oxygens and 4 oxygens. So the oxygens were balanced, but as soon as one thing's not balanced, you're not balanced. All right, let's do this. We got silver to count, hydrogens to count, sulfurs, and oxygens. Notice I'm writing my elements underneath the arrow so that I can count how many are on the reactant side and how many are on the product side. All right, so I have 4 silvers on this side and 4 on this side because that coefficient multiplies through with 2 times 2 is 4. Hydrogen, there's 8 on this side, 8 on that side, right? 4 times 2 and 4 times 2. Sulfur, there's 4 on this side and only 2 on that side. See that? Because this coefficient this subscript is essentially 1. 2 times 1 is 2, so it's not balanced. Are the oxygens balanced? 2, 4. No, oxygens aren't balanced either. Okay. All right, G. Counting bismuth and fluorine. 2 bismuths on this side, 2 on that. Fluorine, 6 on this side, 6 on that. That's balanced. Okay. Notice this one has a polyatomic ion. I'm going to keep it together. So I'm going to count aluminums, nickels, and I'm not going to separate nitrogens and oxygens because they don't separate anywhere. The only nitrogens and oxygens are kept together in the nitrate. Remember, NO3 is a polyatomic ion called nitrate. I'm gonna count that as one thing. All right, so there's 1 aluminum on this side, 1 on this side, 1 nickel on that side, 1 nickel on this side, and there's 2 nitrates on this side, but there's 3 nitrates on this side, so it's not balanced. Okay, I count sodiums, borons, hydrogens, and fluorines. This is going to be a little bit harder because the borons are in all 4 places, so we got to be careful. And there's coefficients on every single one of these molecules. So, all right, so the sodiums on this side are 3, right? 3 times 1. Sodiums on this side are also 3. Borons, there's 3 here, and there's 4 here, so there's 7 borons. And on this side, 2 times 2 is 4, plus another 3. So that's 7. Hydrogen, 3 times 4 is 12. And 2 times 6 is 12. Looking good. Fluorines, 4 times 3 is 12. And on this side, 3 times 4 is 12. Okay, so this one's balanced. Okay, the next one. All right, this one's a huge mess. We cannot count the nitrates separately because notice it breaks up into its nitrogen and oxygen parts in the product here. So this one we are going to have to separately count carbons, hydrogens, nitrogens, and oxygens. And notice there's only one reactant. You're allowed to have just one reactant. It breaks down. This is called a decomposition. It decomposes into all these pieces. Okay. All right, so the carbon, 4 times 3 is 12. The hydrogen, 4 times 5 is 20. The nitrogen, there's 3 times 4 is 12. The oxygens, 3 times 3 is 9. Times 4 is 36. And then on this side, the carbons. Wow, it's instantly... Oh, what did I do? Okay, hold on, I can't do math. I said 4 times 3. Whoops, okay, 12. You were wondering if I was going to fix that. Okay, so on this side, there's 12 also. Oxygens, 10 times 2, hydrogens, 10 times 2 is 20. Nitrogens, 6 times 2 is 12. Oxygens, this is a mess. Let me change color here. All right, so right there, that's 2. Right here, that's 12 times 2, so that's 24. Right here is 10 times 1, that's 10. So 2 plus 24 plus 10 is 36. We're balanced. Smiley face. Okay. All right. This one is a huge mess also. The sulfate stays together. The phosphate kind of does. I don't think we should count the phosphate. I think we should count the phosphate as separating. All right, so we should count calciums, fluorines, phosphoruses. Ugh. You know what? Let's count the phosphates. This is too much of a mess. All right. Hydrogens and sulfates. The sulfate we can definitely count because it doesn't break up. So, all right, let's see how this works out. So there's 1, 2, 3, 4 coefficients here we got to pay attention to. There's no coefficient in front of this. So we can just count normally. All right, so calciums, there's 10. Fluorines, there's 2. Phosphates, there's 6. Because I'm going to count this whole thing, the whole phosphate. Hydrogens, there's 2 here, but there's 7 of the whole thing, so there's 14 hydrogens. Sulfates, remember I'm going to count the whole thing. There's 1 sulfate right here times 7, so there's 7 sulfates. All right, on this side, oh, here we go. Oh, no, okay, there's 3 calciums here and 7 calciums here, so there are 10, okay. Fluorines, there's 2 times 1, so that's 2. The phosphates, there's 1 right there, but it's doubled. So there's 2 right here times 3, so there's 6. The hydrogens, let me do the hydrogens in another color. The hydrogens, there's 2 right here, and there's 2 times 2 is 4, but times this coefficient, there's, okay, but times that coefficient, 4 times 3 is 12, plus these other 2, sorry. So 12 plus 2, yeah, so this is good, that's 14. And then the sulfates, I'm counting them all as one thing. There's 7 of them. So good. All right, that big mess is balanced. All right, so that's page 3.